Hey everyone, in this video we are going to be looking at a simple Hello World AVS example, and we are going to be looking at the GitHub code. We are going to be looking at a simple architecture diagram, as well as we are going to be running it on our terminal. So this is a completely hands-on session, therefore I just prepped a demo for it. So let's do it live. Okay, so the repository where you can find this code is the Hello World AVS repository within the Layer Labs, which is the parent repository of EigenLayer. And before we start the hands-on coding, let's take a look at the architecture diagram. So if you think about designing an AVS, you can think of an AVS functioning within the EigenLayer ecosystem as a concept of like Trinity. So you have three components. There is the AVS itself, which has your business logic, and it should also liaison with the EigenLayer contracts, which is the service manager contract. So it should inherit some components from there. So that's your prime element, which is the AVS itself. And then you have the EigenLayer contracts, which are your service manager and other contracts that manage the AVS related stuff. And then you have the third element of the Trinity is the operator. So the operators are the one that service your AVSs, right? Using their validators and things like that. So you need to have the operator that talks to the AVS, and AVS also talks to the operator. So if you think about those three components, right now in this diagram, in the simple architecture diagram, there's just the two main components, which is AVS and operator, and then the Hello World itself, the AVS Hello World also has the service manager associated with it. So how does the workflow happen? So you have the AVS consumer. So if the AVS is an Oracle, or if the AVS is say a bridge, you have a UI for your dApp, and then you have the consumer, right? So the consumer will request something from the AVS. So in this case, the consumer requests the AVS to say hello world. So the AVS contract in itself is a Hello World Service Manager contract, which we will briefly go through. And this Service Manager contract tells the operator. So the operator is the one that services the request, right, for the AVS. So this operator has this AVS registered with it, and this says that emit the event hello world, say hello world. So the event that the contract emits is say hello world. The operator catches this, creates a message hello world, and adds a signature, right? So the signature is kind of what the operator is providing as a service, and then the message along with the signature is sent back to the Hello World Service Manager contract, which is then serviced to the consumer. So this is a brief sort of idea of what is happening. So you see the AVS consumer requests a hello world message to be generated and signed. The AVS takes on the request by emitting an event for operators to pick up the request. Any operator who's staked to serve this AVS takes this request, generates the message, and signs it. The operator submits the message with their signature back to the AVS. If the operator is in fact registered to the AVS and has the minimum needed stake, the submission is accepted. So in this case, you can see that there is, if operator or stake is greater than the minimum needed stake, then you accept and you emit the event. So this is a simple workflow, right? And then there is of course different other things when you're building the AVS that will matter. That is here it's just a simple hello world message emission and signature request, but of course you have more complex things like when it comes to Oracle, then you have to attest to certain events and things like that. Then there might be multiple operators that need to coordinate with each other, and the type of signature scheme might be different than the service itself, and then the amount that is required to secure the AVS could also be different, right? So multiple other things that will come into place when you're building a real use case, real AVS as your use case. So let's get into the hands-on element of this repository. I already have cloned this repository. So the Hello World AVS, this is the repository that you see over here, and I already have the dependencies installed. So you have a simple npm and then Foundry. If you are a Solidity smart contract developer, then you are very familiar with Foundry, but if not, then Foundry is a tool suite or framework that you can use for both writing and testing your smart contracts in Solidity. So you have Docker, things like Docker containers, so it's a containerized entity. and the different Node.js packages, so TCS, Ethers. So I've already done yarn install. Now there are two types of repositories, one is of TypeScript and one is Rust. So I'm going to go through the Rust one very shortly, and I'm using, so again they have a local chain which is called Anvil. So Anvil comes with Foundry, which is like your Get or your Ganache or something if you're old school, and Holesky is a testnet, that is a proof of work testnet, and I'm going to be using the I'm just using the parameters associated with the Holesky testnet. So the Hello World Service Manager and then your Delegation Manager, AVS Directory, all of these contracts are already deployed on the Holesky address. So what I'm going to run is this command, which is make start Rust operator. So there is some warnings and all of that, blah blah. Okay. So the Hello World contract address is this, which you can see is over here, and then there is the Hello World Service Manager instance, and then there is a new task that is detected. So hello EigenWorld, you can see that the task is created and it is signing and responding to this particular task. So okay, let's look at this code base. I also want to fix some of these spelling mistakes. Okay, so the environment variable that I've used is the Holesky one. So you see the parameters are all Holesky ones. I've added the private key as well, but of course I've hidden it as of now. And then the function that you're actually hitting is this, which is the start operator.rs. So this is a bit of a huge repository. You have the contracts, you have assets, you have the disk, node modules, but we are looking at the operator code as of now. So this is the mock operator written in Rust. Let's see how the operators are working. So I have the Rust, I'm getting into the Rust one, and this is the function that we called, right? Start operator. So it says make start operator. Where is it? Yeah, okay, oh sorry. So start Rust operator, which in turn calls the start operator function, and these are the different things that are happening, right? So the so let's quickly go through this this file. Don't have to worry about all of, there are some checks and all of that. Let's go to the function which is registering. Okay, so you see the register operator. So the register operator is going to just take your local wallet from the key, right? And then it gets the provider, then it gets the Hello World contract address, so which is already deployed, or the contract address is there. And it gets the delegation manager contract, it gets all of these different contracts. And then it, it reads from the chain. So you have these functions that are already coming in from your EigenLayer libraries. So you are reading and then you are writing some instances, and then you are creating a new operator, right? And then you are registering this new operator. So this is the simple function that is happening as of now. So you register as the operator, and then it prints operator registered on EL successfully, right? So you use this function which is register as operator. So use the writer instance which you have created over here, because you need to write some information, and you register the new operator. So once the operator is registered, right, you just calculate a signature and you have the operator signature. Using the operator signature, you are initializing a new ECDSA. This is for the stake registry, but we are not using this extensively, but this also has been successful. Being able to create a new ECDSA stake registry also is successful, because we can see that initialize new ECDSA, right? So this is pretty straightforward. If you are have some Rust expertise, and you're just creating a key with like salt and expiry. So you add the signature which is from your wallet, and then you add the salt and then the expiry for that. Okay, now the next thing that we see is have the Hello World contract. So let's find that. Okay, so the next thing that we are calling is basically trying to sign in response to tasks, right? So the whole idea of this Hello World Service Manager, maybe this is a good time to quickly take a look at the contract itself. There's a bit of reds because of the dependencies and such, just ignore that as of now. So you see here, you have the Hello World Service Manager, which is the contract, right? Which is your AVS as of now. In this situation, this is the AVS. And then it, has some dependencies and such. Now what you're doing in this hello world contract is you have a mapping which is for all task hashes, whatever are the different tasks, a task hash is stored, then latest task number, then you're mapping all the task responses, right? So you get the message and the signature as a response. So and then there's a modifier which is only for operator. In the constructor you initialize all the contract addresses like AVS, directory, stake, registry, delegation manager and all of that. And then you have the function create new task, which is what this particular AVS is doing, right? It's creating a new task, which is actually to say, in this case, it is to print hello world, right? So in this, you create a new task and you have the name of the task, at which block height was it created, all the task hash. So you store the hash of the task on chain, you emit the event and you increase. So you are storing everything in the mapping, right? You are creating a ketchak of the new task and you're storing it in the mapping, and you emit that a new task has been created and you assign it a task number. So you increment that. And then only the operator can respond to the task, right? So AVS creates the task and operator responds to the task. So the operator gets the task and then the reference index for the task and the signature. Right? So then the operator has some conditions that, minimum weight and all of that, and then you check whether the task is valid, and then there's some other logical checks, and then you have the message that was signed. You kind of wrap that into ketchak, the message hash, and then you get the each signed message hash of that, and you recover the signer address. So if the signer is equal to the message sender, then you say that they are not if they are not equal, then they are not the operator. You have you store the response that you get. So you store the task index and the message sender along with the signature, right? So you for this particular task, this is the signature that you're adding. So that's like the response that you're storing, and then you say that okay, I have responded to the task, so you emit an event. Okay, so emit whatever is the index of the task, then whatever is the task itself, and who is the message sender that is responding. So your operator, right? So this is your simple AVS contract itself. And now when we go back to the operator, so your operator should actually sign and respond, right? So here you have the provider. So this is just like getting your wallet from your MetaMask and stuff like that, whatever wallet you use. And then you have the message, which is hello, and then the name, and then you create the hash of the message, you get the wallet, and then you have the signature, and you print signing and responding to task. So over here we have this signing and responding to task, and this is task number, whatever is the index that was created, right? And you have the hello world contract address, so you get the contract address from there, and you get the service manager contract. So both are here, so you have the contract address and the service manager instance, and then you just respond to the task. That's it, right? So this is pretty much like your simple. This is what your operator is doing, and so the next function, or what we see over here, which is monitoring new tasks. So you see there is a function to monitor new tasks. So you have the provider, and then you get the contract address, and you just create a new task, and you say that you are monitoring for new tasks. That's it. So in this, while creating a new task, you create a new task, you send the gas and all of that, and you get the latest process block, and you just keep monitoring till you are able to kind of perform whatever is the final action. So like this, you just keep monitoring until you quit and stuff, right? So okay, now let's quickly just want to see where this is. Okay, so in monitor new task is when you're printing this, and then okay, I found both of these. Okay, so it's the same. So it's gonna build, and then it's gonna create the task, it's gonna monitor the task, and it's just gonna register the operator, initialize the new ECDSA, hello world contract, and the service manager and all of that. Now there is another interesting piece of code in this itself, which is just to be able to create some spam tasks. So you create a bunch of spam tasks and you see what is happening. So the code for that is make spam just tasks. Okay, so this takes a while because you're creating the new tasks, and the code for that you will find over here, where you just generate random names like all of these, and then you generate random tasks, right? And you just, so this hello world contract, in the contract you call this create new task. So we saw the contract, right, which is, so this is the function, you call it with the name, it creates the new task, and then it emits once the task is created. So you just keep creating like new tasks. So this is just like a testing, just for testing. And you can use this in a format that, you know, you can see transaction successful. So every time you're creating a new task, and this is, so I will take the transaction hash and I post it on this whole ski explorer, and you can see success, right? So it called the create task function. You can see the logs that the new task was created with this topic and, you know, task index, the task itself. So yeah, this is a simple sort of, you know, build your own AVS, and you can also follow the tutorial, try some other new stuff like add a new strategy, operator must respond within a certain number of blocks. You can add some extensions. This is very interesting because you can actually see what the architecture is like. You can now try to modify maybe the hello world contract and add something else to it, and make sure to add the respective operator components, say in the Rust file, and try to match, you know, what is happening. So that would be an interesting exercise for sure, because you can see that the Rust file is very closely associated with what the contract is doing. So for example, whenever you're creating a new task, it is, you know, associated with the contract. You just need to call the contract function and you know, perform some monitoring. So you can write some small piece of code to sign and respond to something else. You can change the hash type, or you can add another complex layer to this, that apart from hello world, then you're also maybe asking for some kind of storage or just something interesting that you would like to experiment with. Of course, you can build something more complex like adding oracles like price feeds and getting the operators to actually get the current price feed, sign it off and send it to the AVS, and, you know, different interesting things like that. So it really opens up the door to do a lot of cool stuff, and I'm super excited. Okay, too many requests with the body. Okay, exceeded the quota major. No worries. Alright, so this was a simple, just, you know, run your own Hello World AVS, figure out how it works, and get to build your own stuff just inspired by this. Thank you so much, and thanks for watching.